Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 9 in Geometry, which is about transformations. We're talking about rotations today, which is basically like, it's rotating something. This is called a congruence isometry, or it's an isometry, which means that all the shape, all the size and shape is going to remain the same. It's just going to be kind of reoriented in a different way. Okay? Let's get into it here. So we have no warm-up. The center of rotation in a reflection. A figure is turned about a fixed point. A what? Fixed point, called the center of rotation. An angle of rotation are rays, or what? Rays drawn from the center of rotation to a point in its image. Those form a angle of rotation. All right. And so we have some rules for rotations, okay? So kind of like we've talked about where we basically we did X, Y goes to something, right? I want to actually get away from this. The notation in the book that we used to use and stuff uses AB. I want to use XY because it literally is XY. It's not AB. So we're going to do X, Y to whatever, Y negative X or opposite of X, okay? So just try to get away from, I don't like the AB. I think it's kind of silly. It's like a intermediate step where we have to go back to XY anyways, okay? So here's some rules. So if you want to rotate a shape 90 degrees, the rule is going to be the opposite of Y and X, okay? So for example, the way this works, just to kind of as a review, if we had, for example, say we had the point 1, negative 3, right? So this is X, this is Y. So if we do opposite of Y, opposite of 3, negative 3 is going to be, it's going to be 3. And X is going to just stay as 1. So that's basically we go from here to here. And so that's how we apply that rule for number 1, okay? So if you were to rotate 1, negative 3, 90 degrees, it would end up at 3, 1. Okay? All right, sounds good. Rotation of 180 degrees is going to be the opposite of X and opposite of Y. All right. 270 degrees is going to be Y and the opposite of X. All right. And that applies to these kind of here too. But down here, they goofed this up. This should have been Y and the opposite of X, or I guess B and the opposite of A. So, yeah. All right. Sounds good. So let's do some examples. All right. So we have triangle PQR with those coordinates, and we're rotating at 90 degrees. So let's do this here. So what's the rule? So we're starting with, that's a pretty thick thing here. So we're going to go, we have X and Y. And the rule for a 90-degree rotation is going to be what? It's going to be, let's cooperate here, the opposite of Y and X, okay? So if we do P, Q, and R, which are these coordinates, we have 0, 2, we have 3, 3. So we have 3, 3 for Q, and for R we have 0, 0. So these, if we apply the rule to them, right? So we have P prime, P prime, if we do the opposite of 2, which is Y, that's going to be negative 2, and X is going to stay the same, which is 0. Okay? Why don't you guys see if you can figure out Q and R? Go ahead. All right, so Q prime, opposite of 3, which is Y, is going to be negative 3, and X is going to be just 3. It's going to stay the same. And then we have R prime, well, opposite of 0, which is 0, and then 0 is going to stay the same for X. And that's it. There's our rule. Okay, why don't you guys go ahead and do the checkpoint. It's basically a new triangle ABC, and it's also rotating 180 degrees. So why don't you guys go ahead and give it a try. Okay, so we have triangle ABC. The rule is XY goes to, and it's going to be opposite of X, opposite of Y. So we have A, B, and C. Okay, so we have negative 3, negative 2, negative 4, 2, negative 5, negative 3. All right, and then A prime, so the opposite of X, which is negative 3, is going to be 3, and opposite of negative 2 is going to be 2. B prime, opposite of negative 4 is 4, opposite of 2 is going to be negative 2. And then for C prime, opposite of negative 5 is going to be 5. Opposite of negative 3 is going to be 3. All right, sounds good. Okay, now we're doing a similar thing, but now we're actually going to visualize it here with actual like graph. So yeah, similar thing. We're doing a quadrilateral. It has kind of a funky shape, and we're going to go ahead and we're going to graph it. Okay. And actually, we're gonna do the rules, and we're gonna graph it and see what happens here. Okay. All right. So we're graphing this, or sorry, we're doing a 270-degree rotation. So we're gonna do x, y goes to something, and we have k, l, m, n, and here are the coordinates. We have 3, 2. We have 4, 2. We have 4, -3. And we have 2, -1. Okay? All right. And we have the rule is going to be 270 degrees is going to be y and opposite of x. Looking for k prime, l prime, m prime, and n prime. Why don't you guys see if you can figure those out? Go ahead. Okay, so yeah, so let's go ahead and do this here. So y is going to be 2. Opposite of 3 is going to be -3. For L prime, we're going to get 2, -4. For M prime, -3 goes in front. That's y. Opposite of 4 is -4. And then we have -1 is y. Opposite of 2 is going to be -2. So let's graph these, okay? So we have k. We have 3, 2, right? 3 up 2. That's k. L is right 4 up 2. Actually, why don't you guys go ahead and see if you can graph these if you want to pause the video and do that. It'd be a good idea. All right, and then we have M is right 4 down 3. That is M. And then we have N is right 2 down 1. That's N. All right, and we're going to use dashed lines to show this is where it was. This is the pre-image. Okay. All right, and then we got to graph the other thing here, so let's do that. So we have 2, -3, right 2 down 3. We have right 2 down 4 for L prime. This is K prime, L prime. M prime is left 3 down 4. That is M prime, and then we have N prime, which is left 1 down 2. All right, and these are going to be solid lines to show us is where it rotated, okay? So rotations usually go clockwise, so basically it went here, here, and then it went here, and then it went all the way over here, okay? So yeah, it's kind of hard to see, but hopefully with this 90-degree rotation, it'll be a little bit easier for the checkpoint. Why don't you guys go ahead and do the checkpoint? Go ahead. All right, so we're doing the same points, K, L, M, N, and we're rotating at 90 degrees. So what's the rule going to be? Well, the rule is going to be, we have x, y goes to what? Well, a 90-degree rotation is going to be the opposite of y and x, okay? And we have K, L, M, and N. And the points are, again, 3, 2, 4, 2, 4, -3, and 2, -1. Okay. All right. And K prime is going to be -2, 3. L prime is going to be -2, 4. M prime is going to be 3, 4. And let's see here. Yep, and then N prime is going to be 1, 2. So let's graph these. Start with the red one, right 3 up 2. That's K. Right 4 up 2. That's L. Right 4 down 3. That's M. Right 2 down 1. That's N. Dashed lines to show that's the pre-image. All right, and then we have the rotations. We have -2, 3 is left 2 up 3. That's K prime. Then we have left 2 up 4. Oops, gotta put that out of the way. It's gonna be rotated a little weird. So this is K prime right here. L prime is gonna be left 2 up 4. That's L prime. Then we have right 3 up 4. That's M prime. And right 1 up 2 is going to be N prime. And this is where it rotates. So you can kind of see that, like, basically, like, this axis becomes this axis, right? It basically splits the thing in half. It kind of shifts it. It basically shifts the whole graph. Like, it takes this axis and makes it over here. If it went 180 degrees, it would go over here, right? So that's what it means to do a rotation, okay? All All right, last thing. We talked about this, that rotation is an isometry, which means it maintains congruence, or that the shape and size is the same. So let's go ahead and do this down here. So we have, it says this quadrilateral or shape is rotated. Find the value of y, okay? So the thing here is we want to kind of match up the sides that go together, right? So here's 7y, okay? Now if we rotate this shape 110 degrees, right? Which side matches with 7y? Is it 3x plus 1 or 3x? Well, if you look here, it's actually going to be 3x plus 1, okay? So these two are going to match up, right? So we're looking for the value of y, all right? So we know that 3x plus 1 equals 7y, okay? If you said 3x, that'd be fine, but 3x doesn't match with 7y. It actually matches with what? It matches with 6, okay? So can we solve this one right here or no? The 3x plus 1 equals 7y? We cannot, and the reason why is because we have two variables, right? So what we're going to do is we're going to set 3x equal to 6. We're going to kind of do an intermediate step here. So how do we solve for x now? Divide by 3. We get x equals 2. All right, we're not looking for, I guess we're looking for either one, but I'll just circle this. We're not solving for that. Now how do we solve for y? Well, we can take that x, that 2, we can plug it in for x. So we got 3 times 2 plus 1 equals 7y. 3 times 2 is 6, plus 1 is 7y. So 7 equals 7y. Divide by 7, and y equals 1. All right? So you just got to find the matching sides, solve for anything that you need to be able to solve it, and then you can go ahead and you can solve for the missing thing here, okay? All right, why don't you guys go ahead and do the checkpoint, see how you do. All right, so we're looking for B, all right? So we're rotating this 80 degrees. So we're looking for B. I don't know, what side matches with 4B over here? If you rotate, if you kind of follow the way it goes here, it's actually going to be 2a plus 6. So we know that 2a plus 6 equals 4b. Can we solve that or no? We can't because we have a and b in there. So what are we going to do? Well, we also have, there's nothing, these to be matching here, but there's not a side there. We can't do anything with that. How about 3a and 15? Do those go together? They do. 3a equals 15 because it's an isometry and they're congruent. Divide by 3 to solve for a. A equals 5. Okay, are we done? Not quite. We're looking for b, so we're going to plug that in for a. 5 in for a. Plus 6 equals 4b. 2 times 5 is 10. Plus 6 equals 4b. 16 equals 4b. Divide by 4. And b is going to equal 4. And that's what we're looking for, so we're good. All right, that's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.